What's up, everyone? How's it going today? Yeah, we're gonna be jumping right into stuff because, joke's on me. I did this stream yesterday. I was live for about an hour and a half, and the entire stream was just mute. There was no sound at all. So hopefully that goes a little better today. I guess we'll see what happens, but yeah. So up here in, oh, just give me actually one quick moment here. Hopefully the background music is still playing for you guys there. Okay, so what we're going to do today in this stream is we are going to set up something a little bit like this example here. If I press play, you'll see that I've got this character with a health bar and he's holding a sword. And if I swing my sword, it's going to cause these collisions to pop up here. If I go and I attack the enemy, you can see that they kind of knock back, and up in the top left corner, you'll see that each swing is doing 5 damage, which is also adjusting the health on the health bar. And if you look closely at these collisions here, you might notice that they're kind of far apart and they're not spawning consistently. And that's because they just kind of pop up whenever there's a tick that happens during that animation. And so there's actually another way that we can handle that as well. If I go into the player character and I've got this Boolean trace with capsules, I'm just going to turn that off here. And now if I go back, you'll see that it's actually doing these line traces all the way through the attack. And this is a much more consistent way of doing sword collisions with stuff like this. And so once we set up the capsule collision, we're also going to go ahead and set this up as well. It's a little more heavy duty. As you can see, there's quite a few traces that happen throughout the swing, but it's much better to do it this way, especially if you have really fast attack animations. So that's something we're going to be looking at there as well. Just give me one moment here as I switch over to my other project. Should be over here. And I set this up as a blank project, but I have a few things that are ready to go just to make it a little easier so you guys don't have to sit through like animation retargeting and setting up the actual character and stuff. So I do have a character here that's been set up with animations already, but other than that, nothing else has been done besides making things a little more visually appealing for the recording as well. And I do apologize if there's any lag in the recording. I've been having some problems with my graphics card. So, hopefully the stream holds up okay. So you can see here that I've got the character divided into a base character and a player character. And just one thing I want to go over here quickly is how I set up these base characters, because typically what you would do is you would just sort of like, you set the mesh to what you want it, right? And then you would go in and you would resize your capsule to match your mesh. And then every time you make a new instantiation of a character with a changed mesh, you then have to go in and realign the capsule component. But for bigger games and stuff like that, you're going to have situations where you have a bunch of characters already set up as like data, and that data is going to be, have a mesh included with it. And so rather than having to come in and change stuff for every different type of character, one thing you can do is include variables like the player or the character height and the character width within that data. And I'm just simulating that here with a couple of default values. And in your construction script, you can actually go ahead and assign that capsule component's half height, the relative height of the mesh to match the height, and then the capsule component's radius as well. And then if I come down here to the character height, and let's say I actually want this character to be 90, you can see that that makes the capsule smaller. It keeps the character so that its feet are in line with the bottom of the capsule. And then I could go as well and I can change this width to something like 50, and it's going to make that a really big capsule. Well, in this case, it's kind of like a sphere, but yeah, it makes things a little easier to keep track of here. I'm going to throw that back to something like 28 and the height back to 182. And the first thing we're going to want to do is we are going to want to give our character some sort of sword. And we don't want to give the sword to the base character because it's possible that we might want to introduce some sort of AI that doesn't actually attack or do anything like that. And we don't want to put the sword on the player character either, because the player character, if we do it here, then we're also going to have to set it up every time we do an AI as well. So when you're making combat and stuff like that, it's always good to compartmentalize everything down into their own classes. And if we create a child class of the base character and call it the combat character, and let's open that up here, then we can go to our base character to the class settings and just make this derive from that combat character. And then we can have our AI derive from that as well, and we don't have to worry about setting up this stuff more than once. Okay, and so now that we've got our combat character, we want our combat character to have a weapon of some kind. And depending on how big your game project is, you're going to want to break down your weapon into multiple categories. So what I'm going to do is I'm just going to create a folder called weapons. And then in this folder, I'm going to create a actor. And I'm just going to call this BP base weapon. And then in this base weapon, we're going to want a couple of things that we know every single weapon that we make is going to need. So off this root component here, I'm going to bring in a static mesh, and I'm just going to call this the weapon mesh. But I'm not actually going to set this to anything here. I just want it there for reference so that we can use it later. And then in the variables here, I'm going to make one called damage. And then this is going to be a float. And then I'm also actually going to set one up here called weapon mesh. And then I'm going to set this to a static mesh. And typically this would be something that you're storing in like a data class. And I'll get into why that is in a little bit, but for now we're just going to keep these here. And in the construction script, we can use this weapon mesh here to set the mesh of this. And then I'm going to quickly put these variables here in a category. Where is that? Over here? And that's going to be called weapon info. Just going to drag this up here. And now that we've got our base weapon set up, I'm just going to create a child blueprint class off of this as well. And we can call this the base sword. And then like we did with the character height and width, because I have this variable set up here for the weapon mesh, if I come up here and type sword 01, you can see that once I select that, it actually just changes the weapon to be that sword mesh. And that's exactly what we want because this is our base sword. Over here, we can also set the damage to 20. And if this was all stored in a data class, then all you'd have to do is set it up in some sort of table, and it would all fill itself whenever you spawn in the actor, as long as you set that up in the construction script as well. Okay, so we could go ahead and put this sword right on our character right now, but we don't actually have a socket on the character for this. And maybe I should have set this up ahead of time, but I don't know. It's nice to sort of show. So I'm just going to go in here to the, not materials. Let's pull up the skeleton here. And I'm going to grab the right hand and then add a socket. I'm going to leave it called hand R socket, just because I'm familiar with that terminology. But to make sure that our weapon is aligned the correct way, we can right click on that and add a preview mesh. And I can add the preview mesh for sword 01. And because I'm using a package that has all of the assets set up the same way, if this sword looks good in the player's hand, every sword will look good in the character's hand. So just to make sure that we do know that this is going to look good within animations, you can come up here and set the preview animation. And I'm just going to set this to attack 3 because I know this one has the most information that I'm going to want to use here. And then I'm going to pause it right here when he's got his hand down against the ground. Because at this point, the sword should be visible in the character's hand, but it also should be flat against the ground. And that's going to make it really easy to figure out exactly where I want this. So the first thing we want is for this to be facing the right way. So we can rotate it 90 degrees this way. I think 80 will be okay. We can rotate it such like this. And then we just want to position it in the hand here. So it's actually something more like that. And you can see that these assets were made for each other, but they're not really... They don't work very well together. I don't know why that is, but it's not terrible. The problem with this animation is that the hand isn't quite tilted properly, so the sword is going to look like it's kind of up in the air, unless it's a little offset from the actual hand itself, which is why I test with this animation. It doesn't look terrible from a distance, but when you're close up, you can kind of see that it's not exactly maybe where it should be. But we're going to ignore that for the sake of this looking right from a distance, because this is a third-person game. And once we've got this set up here, we can go ahead and just right-click on here and remove all attached assets. And can I set this to none? Doesn't look like it, so that's cool. We can just leave this animation here for now. Actually, well, I could come in here and go idle. And there we go. So now we have our socket set up. We can come to our combat character. And then if I click on the mesh here, I'm just going to drop in a child actor. I'm going to call that the weapon actor. And then if you come over here to the right where it says child actor class, I'm just going to drop in a base. If you're doing this with data classes and stuff, you'd want to use the base weapon, because then you can kind of change any sort of base weapon, including your base swords and then any other kind of base weapon that you might have. But for this example, I'm just going to use the base sword itself, because it's the one that has the mesh that we know we're going to want, and we don't have anything modularly set up. So once we've got that here, we can come over to the parent socket and use our hand R socket, and that is pretty much good to go. Now our character is holding a sword, and we can run around. And if I come over here, I can go to the characters and just drop in a combat character for us to do testing with. So you can see that we can't actually do anything yet. We can't attack or... Oh, and I do that every time. Let's go back to our base weapon here quick. Because we're going to be creating collisions for our weapons on the fly, this weapon mesh here should not have collisions. It will cause problems like you could see with that other character sort of hopping around there. So now if you turn that off and then you come over here, you can see that there's no weird collision issues anymore because the sword doesn't have collision. And that's the way you want it. So I could go ahead and set all of this up in just one big fell swoop, but it's probably a little better for... Yeah, it's just better to set things up in a logical process, I find. So we're kind of going to tackle this one bit at a time. So the first thing we're going to want to do is we're going to want our character to be able to attack. So what I'm going to do is I'm going to create a variable called isAttacking. And then in here, I'm going to create a custom event called trigger attack. We want to check to see if we are attacking. And just to make things a little more explicit, I'm going to put the not boolean in here. So if we are not attacking, we want to set attacking to true. And we can play an attack montage, which we actually have not set up yet. So let's quickly go in here to the animations. And then off attack 1, I'm just going to go up here to create anim montage. I'm going to pause this here. And then we're going to want to set up a few notifies here just to make sure that we can trigger events to happen during certain parts of the animation. And the first one is going to be right about here. This is going to be the attack start. So I'm going to add a new notify and call this swing start. And then we're going to drag through here a little bit to find where the swing ends. Right about here, I'm going to say. And you can't right click here because it's going to do stuff with that notify. So I'm actually going to right click over here, go new notify and swing end. Just drag that over here. And we're also going to want to know at what point during this animation the character is allowed to attack again. So the swing starts, it goes through, the swing ends. And before the foot starts coming forward here, right about here, we're going to allow the character to do their next attack. So I'm going to drop in a new notify and call this attack end. Maybe that's even a little too late. So let's go about here. And then once the character looks like they're done their attack entirely and they're ready to go after an entire combo is over, just about maybe here, I'm going to right click over here, add a new notify, and we're going to call this combo break. Okay, and we're going to want these notifies in every single one of our animations because it's going to allow us to have a modular attack combo where you can have 1, 2, 6, however many attack animations you want, and you can add and remove them at runtime or whatever, and it'll all just kind of work. So now that we've got this set up here in our animation, I'm going to come back to the player character here where we've got trigger attack, or sorry, the combat character. Don't put this in the player character, you'll have a bad time. I'm going to drag off of here and I'm going to go play montage. And you want the one with the little function symbol in front of it because this was made specifically for characters, just to make your life a little easier. So I'm going to drop that montage in here just for now, just so we can test it out. Come over here, and we also need to activate the input, which isn't the player character. So once we've started here, because the player character derives from the combat character, we can just drag off of here and go event trigger attack. And you'll notice when I do the attack that the character sort of steps forward, but nothing actually happens. And that is because if I go over to the animation blueprint, if I go over here, we need to define what slots this animation blueprint is able to display. And because we haven't set a slot for our animation montage, we just need to make sure we activate the default slot in our blueprint, and anything that hasn't been defined will play here. So now the attack animation happens, but we can only attack once. And that's because we need to use these notifies that we set up here. So in the animation blueprint as well, I don't like doing this in the event graph because it makes things a little messy. So what I'm going to do is go over here and we're actually going to create a new graph called the notify graph. And in the notify graph, we are going to do things very weirdly for the sake of testing. And then near the end of the stream, once everything is set up and ready to go, we're actually going to go back over things and refactor them to work a little better, just in case you want to make things more expansive. And I really don't like showing messy code. But for the sake of testing and for streaming, you need to start somewhere, right? So what I'm going to do here is I'm going to right click on our notify graph and I am going to type notify. And if I scroll up here, you can see all of the anim notifies that are attached to this skeleton. And just so that we have them here, I'm going to drop them all in right now. But we're not going to need them all right away. Our attack ends and our... Okay, so the first one we're going to want to activate here is actually the attack end. One thing that I do when I set up my animation graphs here is I initialize the animation ahead of time, so that rather than having to cast the character every single update, I only cast the character once here. I think this is how Unreal Engine 5 does it by default now, but I've been doing this since Unreal Engine 4, I don't know. I find this really helpful, it makes things very easy. And on the notify graph here, what that also allows us to do is just grab our variable, convert that to validated get, and we're going to have to do a cast here. This is one thing we're going to come back and refactor later, However, when you're doing casts, you also kind of want to think about retroactively how you're going to change it later. Casting is not exactly the best thing, and I could come in here and I could change or add another variable here to make this the combat character rather than the character itself, so that we can call these functions directly. However, once you remove casting from the equation, that actually adds more work, because not only are you still going to have to come over here and change the variable itself to something else in all of these instances, you're also no longer going to have a need for the variable or the original cast at all, and you're going to have to remember to change that too. So for now, I'm just going to throw a bunch of casts in here, but we're going to change it later. Don't worry too much about that. Off of the owning character here, I want to cast this to the combat character. And off the combat character here on attack end, we're going to call a function called attack end. So we're going to come over here, custom event attack end. And this is going to tell our attack variable to turn false so that we can do a second swing. Or however many swings we want, really. So now if I swing the sword, you can see that we get as many swings as we want, but we still can't damage our enemy here because we haven't set up any collision. In fact, we turned off the only collision we had because it was causing issues. So, the first step we're going to want to do to be able to create collisions for this weapon is to add sockets to the weapon. If your weapon is modular, you're going to want to add the sockets probably to the blade, or however you want to do that. But my weapon is just straight up a sword. So I'm going to open it here and go to my socket manager. If you don't have a socket manager, you can find that up here in the window, socket manager. And I'm just going to throw in 2 sockets. I'm going to call this socket 0, and then add in socket 1. And for socket 0, I'm going to put that near the bottom of the handle here, just to make sure that if an enemy is too close to the player, it's still going to trigger that animation, collision. And then I'm going to drag socket 1 all the way up to the top here. And there is going to be a little bit of a buffer on this range, so you don't want to put it way outside the weapon, or it's going to cause unfair collisions, especially if it's an enemy against the player. So just make sure that it's somewhere near the top of your weapon there, but not too far down. And then same with this, you don't want it to be all the way down, or else you're going to get unfair collisions. So just make sure that you've got that set up how it best works for you. And you can add more than 2 as well, depending on what the shape of your weapon is, and that'll work just fine. Okay, so I'm going to come back into the animation here now, and we do need to set up one more thing just to make these collisions work. And that's going to require another notify graph here. So you can drop that in, and what we're going to do now is in the animations folder, I'm going to make a new folder called notify states. And then we can go to the blueprint class, drop this down, and type notify state. And we're going to make an anim notify state. Call this ns attack collision, I guess. And then in here is where we're going to define how the collisions are going to appear with the weapon. If I go over here to the functions and drop down the override, these are the 3 here that you're mainly going to be working with, begin, end, and tick. However, all we really need right now is the end and the tick. So I'm going to go to the end function here. I'm just going to make sure that this is true, because that's always going to have to be true. And then I'm going to make a variable called hit actors. And this isn't something that you want to do too often in a notify state, because these variables are not consistent. However, or what's the term for it? They're not persistent. However, because of the way that actor references work, this does work in this case, and so we can go ahead and use that here. And once our notify state ends, we're just going to want to drag this off, and we are going to want to clear it to make sure that when we start our next attack, that this array doesn't have anything in it. And the reason we're doing this is because during an attack swing, you're going to have multiple collisions colliding with the enemy or the player. And this just makes sure that the attack is only going to trigger once per swing. Okay. And in here is going to be the first place where maybe we want to set up some sort of interface. Because when we receive our notify tick, we're going to get the mesh component, which is the mesh component of the mesh that is animated, which in our case is going to be the character itself, this thing right here. And to be able to successfully do this collisions, we need access to the weapon, and not even the weapon actor, but just the weapon mesh itself. So I'm going to go back up here to the blueprints, and we're going to make another folder called interface. And then I'm going to make another folder in here called combat. And you'll see why I'm doing that in a moment. But in here, we're going to make a blueprint interface, and I'm just going to call this BPI combat. And the first thing we're going to want to put in here is get weapon. Down here, we can add a output, make this a base weapon type. And I'm just going to call this return value. And then if we go to our combat character in the class settings, we can add that interface here. And adding BPI in front of stuff is not only good for naming convention, but everything you make BPI will appear right here near the top of the list, and it makes it very easy. So I can go into the get weapon here. And this is where we're going to want to do a little bit extra work. Because to get the weapon, we're going to have to go off of here and go get child actor. And then this child actor is actually just like a basic type. Then we have to drag off of here and cast to the base weapon. And then even after we've got this weapon, we still need to go into our notify state, go off of here and go get weapon. Oh, actually, my bad. We're going to want to get the owner first. That's going to get the owning actor of the mesh component that's animated. And then we can call the interface get weapon. And then once we've got this, we have to go off here and go get weapon mesh. And that's not too bad to have to do this one time, but every single time you're going to want to access the sockets from your weapon, you're going to have to go through this whole process. And especially with interface functions, the main thing about them, even though we're setting this up on the combat character so that we don't have to worry too much about it, you do have to define this function every single time you want to use it with an actor. So what I like to do when I have interfaces as well, is I like to come in here and add another blueprint, a blueprint function library. And I'm going to call this combat functions. And this is just going to allow us to define a little bit of base logic that we can then implement every time we call interfaces and sort of mix and match the different packages, if you will, just to make sure that we get the broad functionality we need without having to rewrite too much on the fly. And so the first thing we're going to want to do is make the function here called get weapon mesh. And to get the weapon mesh, all we want to pass it is an actor. We don't care what the actor is, it can just be any kind of actor. So I'm going to call this the actor. And this is going to return a static mesh. We don't care what kind of static mesh it is, it can be anything that we want. We call this return value. So if we go to our combat character here, we've got all of this stuff here with the weapon actor, the child actor, to the base weapon class. We've got our whole thing there. But we can do that here in one way or another. How do I want to set this up here? Oh, you know what? That's my mistake. This is what we're doing. This right here, we don't want this to be an actor. We actually want this to be the combat character. And that's the reason that this is being defined in the combat functions. That's my mistake. And then off the combat character here, we can get the weapon actor. Then we can go in here. We can just grab this section here. We can cast that to our base weapon. Then we can get our weapon mesh. Throw that in here. Oh, you know what? I've made another mistake. I've gone and done that all in one function. This is going to be our get weapon. The joys of being live. I'm going to call this a base weapon. And that's going to be the return value here. And then we want to create another function called get weapon mesh. I'm going to fix that capital there because that's going to drive me crazy. And then in get weapon mesh, we can call our get weapon. We're going to want to pass in the same combat character, which will also be our world context. And then in this function, what we're going to return is the static mesh. And here we can go get weapon mesh. And again, another little mistake here. This can actually be of type base weapon. We do want to make sure that it's broken down to make things as easy as possible. This way it's expansive and it's not too cumbersome to re-implement. So now every time we do this interface function here for get weapon, we can just type get weapon, and you want to call the function library get weapon. Then we can just go in here and go self. And then in our notify state, wherever that's popped up, rather than having to do all of this, that's a way you can do it anyway. Maybe that's a little redundant in this case, but it's definitely helpful when you have bigger projects to get things done this way. We can type get weapon mesh here. And then we've got our function here for get weapon mesh. And we want our world context object to be the owning actor there. Just to make things a little bit easier since this is here. Another thing that we can return here. Okay, this function library is going to be helpful, but maybe we actually don't want this right now. In our blueprint interface here, I did a little bit of testing on this. Like I said, I did this stream yesterday, but yeah, I'm trying to do things a little bit more expansive here. I figured I got a little bit of practice in yesterday, so we might as well do things better. And it's always fun to try and do new things live because you don't know exactly how it's going to go. What we're going to do here on the blueprint interface, under get weapon, I'm going to make another function here called get weapon sockets. And this is going to return a vector array. And we're going to actually just completely ignore this function library for now. We'll come back to that once things are a little more complete. So I'm going to delete that here. We should be able to delete it. No, I still have it in here. Okay. And then we should be able to delete this here. Then in our combat character, we want to get this. Get actor. That's to base weapon. Return that here. Then over here, we've got that. And then in our character as well, we're going to define our get weapon sockets. And this is just going to allow us to get all of the sockets we're going to want to use for our collision without having to name them individually once we pull our weapon off. Because once we go over here, we can go get weapon mesh and get socket location. Oh. Get location. Get socket. What the heck? Find socket. Get location. Okay, this is weird. This is a static mesh, right? Okay, now I'm confused because this is exactly how I did it yesterday. We got a base weapon. We get our weapon mesh. What if I go in here? Yeah, right here. Get socket location with the weapon mesh. That's what's supposed to be coming up here, but it's not. This is a static mesh object. If I come over here, what is this giving me? Static mesh component object. Okay, so that's what we're doing here. That's what we're doing wrong. Let's go into our blueprint interface. Well, I must have just accidentally done this correctly the last time I did this. Oh, nope, you know. Yes. Fun. So this... Wait. Gotcha. Yes, we've set up this variable so that we can define what our weapon mesh is in the construction script. So you just want to make sure that you grab the right one here. Once you've got this weapon mesh, we can go get socket location. And then we have to name each location individually. So this is socket 0 and socket 1. But if you have to do this every single time you want to do one of these traces, it's going to become pretty tedious, especially once we get into the line trace method that's going to trace lines all the way through our swing, because we're going to have to do that about 4 times. So I'm just going to X this out over here, go to our combat character, and we can get our weapon actor, get child actor. Let's go get weapon. Drag that in here, do this, and make array. And then depending on your weapon, you can also pass in an array through something like this to make that easier and more modular, but this works for us here. Just gonna save us a little bit of time. And then in here, I can go get weapon sockets. And then we don't even have to get the weapon at all. And we only have the 2 locations, so I'm just going to go get 0 and get 1. But it is going to save us from having to type the names and everything like that. And then in here, I'm going to go multi-sphere trace for objects. This is going to allow us to easily trace for only pawns, which we can define here with the object types. If you want to hit stuff in your level as well, you can go ahead and add pins, like world static, world dynamic, whatever you want. But we don't need that for now. I'm going to set the radius here to something just like 15. And just so we can see what's going on, I'm going to set the debug to duration. This is mad at us because we don't have a world context object. So if we make sure that the world context object of this trace is the actor that's committing the attack, what's going to happen is that actor is going to automatically be ignored by the trace. So we're not going to have to worry about doing any other logic to make sure that that happens. And like I said, this is where we're going to want that function library. I'm not sure why I outright deleted it, but right here, this function is going to be called about 6 times in our logic. So I'm going to come in here and I'm going to make the function library combat functions. Open that up here and I'm going to go trace attack. Damage trace. This is going to take a couple of inputs. It's going to need two vectors, the start and the end. It's going to want this object types here as well, which are an array of object types. So I should just be able to find that in here by typing object types. And there we go. Object object type query. That's what we're looking for there. And then I'm going to drop in a Boolean here as well called show debug. Then we can come over here to this. I'm just going to grab this, X that out, paste that in here. Drag our start and our end. Object types should be an array. And off of this show debug here, I'm going to make a select node. Drag in this Boolean. And if we are showing debug, we want this to be duration. And if we're not, we're just going to leave this at none. So this is going to avoid us from having to do too much work with this multi-sphere trace. The only other things that we need to throw in here, just to make sure we know what we've got, is we want to throw in the actor that is doing the attack. So instigator? Oh, gotta be an actor in that section. It's gonna be a single instigator. I know I'm spelling that like an alligator. I'm not sure if that's correct. I'm just gonna fly with it. Then over here, we can go damage trace. And set this stuff up here. Remove that. And I'm not sure why I deleted the object types here. Let's go ahead and throw those back in quick because we're not always going to want those to be the same. We can also make our own at some point. The instigator also has to be the world context object. And we do want to show debug. So now that we've got this set up here, we're going to want this to return any actors that we hit. So we can go off of here and we can go a for each loop. And we're going to break this down. And then under the local variables, I'm going to type hit actors. We're going to make this an actor array, which we can do in this case just by right-clicking on it there. And this is where we're going to need our next function in our blueprint interface. I still have that up here. I think I closed it. Let's pop that up. And in here, we're going to want to make a function called isDamageable, which is just going to return a Boolean. And because we don't really have any iframe logic or anything like that, we just want to go in here and set this to always be true. And then in our function library, we can drag off of this hit actor and go isDamageable. If the actor that's hit doesn't implement the combat interface, this will just always return false, so you don't need to worry about that. But if this actor is damageable, then we can go over here and we can add unique to the hit actors, and we can add that in here. And once we're done, I'm going to drag a return node off of here, and we can just drag in our hit actors and rename that over here. And that's going to handle all of this logic for us. Hit actors is not blueprint visible. Pardon me? Interesting. Hit actors is not blueprint visible. No, because it's a local variable in a function library. That's strange. Is there any way that I can fix that here, maybe? That's bizarre. Wait, I can't add unique to it either? What is happening? That's strange. I do this all the time. They've finally gone and deprecated that, eh? Well, that's a shame. That's what happens when you try new things live. Okay, so the function library is going to be completely useless for us, it seems. That trick no longer works. They are going to make it deprecated in a future version. That future version is now. So let's go back to our notify state. And we are just not going to use that because, once again, Unreal Engine 5 has screwed me. So let's just throw in this world context, throw these in here, throw in our object types. And we can grab this for each loop and bring that in here as well. And because we're doing this all directly in our notify state, there's actually a couple of things we're going to want to do here. We're not just going to want to check to see if it's damageable, but that is going to be part of it as well. So we want to see if the hit actor is damageable. But I'm actually going to drag off of here and go end boolean. And we also want to know if our hit actor is not contained within this hit actors array. So I'm going to type contains. I'm going to drag off a not boolean. And then just drag this hit actor into here. And if they've gone and updated this overnight, I'm going to be very upset. Okay, that seems to work still. So once we know that our actor is damageable and it's not been hit by this swing yet, we can come over here and we can go add unique. We're just going to drag this over here as well. And I'm going to make a note on this one, because we are also going to want to take this and damage. This damage here we're going to get from our weapon class, which we're actually not accessing at all over here because we have this get weapon sockets. I'm just going to drag this out over here. Add a node over here. Go get weapon. And then we can just save this as a local variable here. Drag this out and go current weapon. And then down here for our damage, we can get the current weapon and get damage. If I could spell damage properly. Our event instigator will be our mesh comp get owner. We don't have to worry about storing that in an extra variable because it's already there for us. And the instigator wants a controller. And if I remember from yesterday, if I go get controller, they've actually removed the ability to get whatever controller is on a character. You either need the player character or the AI controller now. There is no generic one. So I'm just going to leave that blank because we're not really going to use that. Okay, so this is going to allow us to do damage to our enemy. Once we've gone and run this here, we just want to make sure that this is a check mark. And in the combat character, we want to make sure that they actually have a way of accepting that damage. So I'm just going to go up here and go custom event. Oh, actually, we don't want that. We just want to go here and take damage. Any damage. Event any damage. And I'm just going to drop in a print string here for now, so we know what's happening. Going to go append. And actor took that much damage. Once they've taken the damage, we also want to apply a little bit of a knockback. I'm going to launch the character. And to find the direction, we do know who the damage causer is, so I'm going to get the actor location. And we can also get the actor location for ourselves. Go find look at rotation, starting at the hit actor. And we can also go in here and set the actor rotation, so that whenever we hit something, that enemy will turn to face us. And we also want to use this rotation. Go get forward vector. And we're going to multiply this by a negative number so it goes backwards. Change that to a float, and I'm just going to go something like 480. Oh, 480. We want to override the Z and the X, because one thing we're going to want to do as well here is just add a little bit of an X buffer to this vector. If I go in here, and let's just make sure this is working. Oh, whoopsie. Let's go back to our notify here. We've added this, this graph here, but we haven't actually put in our state yet. So go to add notify state, NS attack collision. And you just want it to start when the swing starts and end when the swing ends. Now, we are still not getting anything. Did I not show the debug again? I did not show the debug again. The joys of doing this live. So there we go. Now we've got our attack. And you can see that when we hit the enemy, they do get knocked back and they do take 20 damage. But they don't get knocked back a whole lot. And that's just because the collision is also scraping against the ground. So if I go and I give this a little pop up on the Z of 60 as well, it's going to fly a little bit farther. And that's kind of more what we want. Our attack looks kind of weird though, with just the one animation. So I'm going to go ahead and set up the second attack animation as well. And then we're also going to go ahead and make the combo a little bit more modular. So I'm just going to pause this in here. See here, swing starts about, let's say here. Add notify swing start. Go over here, add notify swing end. About here, maybe notify attack end. And away here at the end, we can add the notify for combo break. And I'm going to add another notify track. And we can also add our state for the collision. And in our combat character here, where are we triggering the attack? We check to see if we're attacking, and if we're not, we just run whatever attack we have here. But if we're going to have a combo, we want to keep track of which current combo attack we're on. So I'm going to call this current combo. It's going to be of type integer. And then I'm also going to make another variable here called combo animations. And this could also come from a data file with your weapon or however you want to do that. And I'm just going to make these of type anim montage. And I'm going to right click to make it an array. compile that up here, and then I can go ahead and add attack 1 and attack 2. And before we actually trigger that we're attacking at all, we just want to come in here and we want to make sure that our current combo is less than the length of our combo animations. Because if they're equal, then that means our combo is too high. Or if it's higher, then obviously it's way too high. So we'll go in here. And if it's possible to do a combo at our current combo state, then attacking is true. And we are going to get a copy of our current combo's montage, play that montage, and then because another attack can't happen until that montage has designated the attack is over, we can just go ahead and increment our combo right away here. Now, you'll see when I swing my sword, I can do the second attack. And once the combo is over, I can't attack anymore. And that's because we now need to use our combo break notify. Over here, we've got the attack end. I'm gonna make another custom event and call this event combo break. Not sure why I put an underscore in here. That's not the naming convention for events. And on combo break, we just want to make sure that we set our combo back to 0 so the attacks will start over. And that'll also make sure that even though we're not attacking anymore, because our combo isn't being reset right away, it's not actually going to allow us to attack again anyway until the combo has been reset to 0. And then on our animation blueprint, at combo break, we're still doing things a little messy right now, but that's okay. We're just going to drop this down here and go combo break. So now, once the combo is over, it'll wait until he's basically stood up, and then the next attack can start. And maybe I'm being a little nitpicky, but this doesn't look quite right in here. The attack end is a little late. I'm actually going to drag it in maybe out here. And we can't really tell for combo number 2 where it is right now, but I'm going to move that a little bit forward as well. I think I was being too generous. Okay. So now we can hit our enemy here and we have our attack combo all set up. And just to see how convenient that makes things here, I'm actually going to go ahead and set up the third attack as well. Set up the anim montage here. Give that a pause. Let's see, swing starts about here. Go ahead, drop in our swing start. Got our swing end right about here. Gonna give it a little bit of a buffer. And then if you know that this is going to be the last attack in your attack animation, you don't really have to include the attack end here. But because I'm not resetting the attack boolean on combo break, I'm only resetting it on attack end, I am going to throw it in here as well. And it also just does allow the benefit of being able to decide exactly how many attack montages you want on the fly. You could give some sort of skill to your character that allows them to learn more attacks and then just kind of add and remove to the array as needed. But we are always going to need to come to the end here and add the combo break. That's just going to make sure that the combo can restart once the animation is over. And all we need to do to implement that attack into our combo is come to the combat character, come to our combo animations, and add that in right here. And just like that, we've now got a 3-attack combo. But I forgot to add the notify state in there. So let's just add that second track. Add in the notify state. Start on start and end on end. And now the combo is set up and good to go. You'll see that that triggers every time we hit the enemy. But there's one more thing we're going to want to do with our attack itself before we move on to the next method here. And that is this little bit right here. I'm currently holding right when I start my attack, but the character just keeps moving forward. And that's because when an animation montage is playing, you can't really do anything to your character in regards of the character movement. And to fix that, one thing we can do is just manually rotate the character before we start an attack swing. And to do that here on the event graph, I'm going to go up here I'm going to get the character movement and get last input vector. And if this does not equal 0, then we're going to grab this and we are going to promote it to a variable called last input vector. This is going to make sure that if you're not holding any input at all, it's still going to save the last input you used rather than having this set to 0. And once the attack has been triggered, but before the montage starts, we want to set actor rotation. We can get our last input vector, rotation from vector. And you're probably not going to have to deal with this being on multiple axes. The input vector is already designated to only being one axis, but I like to do this just for, you know, because it makes things look a little messier, I guess, but it works better. It's kind of how you're supposed to do things. And now I attack once, I hold right, and the character will rotate into the next attack, exactly where I'm holding my input. So if I go over here and I start attacking, you can see that right was maybe too far, but it does mean that if you hold forward and turn your camera, you will always be attacking forward. This also works if you have like an auto-targeting system so that the camera always follows your opponent. Your character will always be facing that center as long as you're holding forward. Okay, so now that we've got that in here, we're just going to go ahead and look at the second method of collisions as well, which is going to be the traces that go all the way through the swing. And to do that, unfortunately, we actually can't use a notify state. It just has to do with the way that variables work when you're doing stuff like this, as you would have seen in the function library if you were hanging out back then. And yeah, so we're going to have to do this all in the combat character, but we can utilize functions from our function library to make that a little easier. Hey, can you make combat like Devil May Cry 5? Sorry, I didn't answer that. It looks like you're gone now. My bad. But if you're watching this after it's gone up as a VOD, I could. There's a lot of air combat in that, and it's a lot more than would be set up in a live stream for an hour and a bit, but I will definitely keep that in mind because I actually did have a thought implementing something sort of similar to Senua's Sacrifice. So perhaps I'll look at Devil May Cry instead. I don't know. We'll see how that goes. Okay, so to start with our second attack combo type here, collision type here, what we're going to want to do is come to our combat character, and we're going to be creating events that will activate a boolean that we're going to call is swinging. This boolean is just going to let us know whether or not we want to do the attack traces. And we can turn it on and off with custom event attack start. And then we're also going to be using our attack end because we already have that set up and ready to go. No, the attack end is different. This is actually going to be swing start, just like we called our notify state. And then down here I can go custom event swing end. Then drag in this boolean, and when we start, turn it on. When we stop, turn it off. Really quick, just so we don't forget, in the blueprint, I was going to say blueprint function library, in our animation blueprint here, we can just copy these, and now you're probably seeing why this is very tedious, but again, we'll fix that once we know exactly what we need. And off of here, we're going to want to go swing start and swing end. Okay. Now that we know when we're swinging and when we're not, we can go to our event tick here, which things are starting to look a little hectic, but we'll get there. We'll make it work. I'm gonna come over here and I am going to add a sequence. So this is going to happen on sequence run 1. And then on sequence rung 2, I'm gonna actually drop in another sequence. And we'll probably collapse this down here in a moment. But we're gonna need 5 rungs on here. Then we can just go back to our notify state. And, I mean, pretty much copy this entire thing. So for get weapon, we are going to be accessing ourself. So I'm just going to drop that in here. You know what? Actually, I'm going to not put that at the beginning. But we do want our weapon sockets. So I'm going to drop that in here. And this is going to be a little different than the way that it was done originally, because in the first method, we're tracing from socket 0 to socket 1 of our weapon every single tick. And rather than doing that with this method, we actually want to trace from a previous location to a current location. And that's going to allow us to trace all the way through our swing rather than just trace each individual instance. And to do that, if we come down here to our swing start and our swing end, when we start a swing, we're going to need another variable in here to keep track of our hit actors, which is going to be an actor array. And that should update some of these here. We've got our current weapon for damage, mesh component owner, we don't need to worry about that. Damage causer will be self. And then for our damage, we can get our weapon here. I think I just got a little sidetracked. Okay, so that's going to set up all of this here as we want it. However, when our swing starts, there's a couple of things we're going to want to do here, such as we're going to clear our hit actors to get that ready for the next swing. And we're going to do that before this Boolean turns on, just to make sure that there's no overlap there or anything. And the other thing we want to do before our swing starts is I'm going to create a couple of variables here called previous sockets. So I'll create one variable. And then I'm going to clear that. Actually, it's going to go ahead and set that by doing this. Then we can make array. Actually, we don't even have to make array because we can just go get weapon sockets and set that directly. Actually, we're not going to want to do that here, and I'll go into why in a moment. So to make this easier, I'm actually just going to make this a single. And I'm going to call this previous socket 0 and previous socket 1. And the joys of doing stuff live. Live stuff. Okay. So now let's implement all of this fun stuff here. For our first swing, we get our weapon sockets, and we are going to right, okay, that's what we want to do. When we start a swing, before we do anything, we do want to set our previous sockets, just so that nothing is directly at the world 0 when we actually do our first attack. So I've gone and typed previous in full there. So we can do this. I'm going to get our weapon sockets. And we can get a copy of 0 and get a copy of 1. And you can set this up in a more modular way if you have more sockets for your weapon. That's not too hard to do, but again, I don't want to go too far off the path of what I set up in the stream yesterday, because things are not going great right now in terms of things going wrong, and I guess that's why live is fun, but live. Okay, so now we've set our previous sockets here. That's going to make sure that when we do a swing, nothing is going to be initializing to world 0. And up here, we want to get our weapon sockets. We're going to want to get socket 0, but that's actually going to be our end point. And our start point is going to be the previous socket 0, which is going to allow us, rather than tracing the weapon mesh entirely, it's going to trace a line from socket 0 all the way through the swing. I'm going to leave the radius at about 15. It's not too much of a big deal here. It's going to go through, it's going to check to see if the actors are damageable and whether or not they've been traced. If they haven't, we're going to add unique, we're going to do that, we're going to apply damage. And then over here, we want to set previous socket 0 to the current socket 0. And we can do that just like this over here. And the reason I'm putting this function over here again is because these nodes here are pure nodes. And what that means is it doesn't actually store a reference to a variable for this. It just kind of gives you the reference that comes from this function. So, and once this function has run a single time, it does store a variable for this here. But if we were to drag this node from here all the way over to here, it is going to run that function a second time. So it just makes as much sense to do this. Makes things a little more readable. And that's going to be for our first socket, for socket 0. And just so you can see what that's doing here, to make sure that this is working correctly, I'm going to go in here, and you can see that it's tracing constantly. And it is going to world 0 there, because I haven't swung yet, so it hasn't actually initialized anything. Oof. Boy. But what we want to do is we want to make sure that it's only going to be doing these traces after we've started swinging, which was the whole point we set up this boolean in the first place. So I'm going to drag this in here. If is swinging is true, and we can run all of these nice collision checks here. Now you can see that nothing is happening, but when I swing, we're going to want to turn this off as well. We're getting there. Okay. So now, when I swing, we're getting there. We're getting there. Set weapon socket, set previous socket. That should be fine. Previous socket 0 to the current. Set previous 0 to the current. I'm not sure why that's happening. I'm not sure why that is happening. So I'm going to set this when the swing starts rather than when the swing ends, or rather than when the attack starts. That's going to fix the first issue there. So now you can see that they all reside at the beginning right there. That's not exactly what we're looking for. So we're setting socket 0 here. And then up here, if swinging is true, we are going from previous 0 to the current socket. We're doing a for each loop. Gotcha, okay. So this is actually only resetting the socket's location if we hit anything. If we don't hit anything, we still want to reset that socket. So you're gonna want that down here off of the complete. I'm not sure why I forgot that. And there you go. Now you can see that the swing is going to trace all the way through. And it is already going to work for all of our attacks because that's just the way we set it up. But obviously you're going to want something a little more robust than this to trace your attacks. So that's why we've gone ahead and added a bunch of rungs here. This is going to get very messy, and that's why I said we're going to collapse it. And the main thing is we don't want to have to call this as this is a bunch of times, because anytime we have to make a change, we're going to have to change all of them. So because we're using these variables and they're stored in our combat character here already, whether or not we're going to have this in a function, we can just go ahead and drop this into a function. So I'm going to go here, collapse to function, and I'm going to call this damage trace. And the only thing we're going to want to change in here is our sockets, because right now this is always going to trace from previous 0 to current 0. And we're going to want to change that depending on which attack we're doing. So I'm just going to pass in a start and an end here. I'm going to go start and end. And we don't need that. We do want our object type to be the same all the time, just to make things a little easier for us. And I'm just going to make things easier as well and drop in a boolean here called show debug. Drag off of here and go select. If it's true, we want for duration, and if it's false, we want none. And we can copy that, bring it back to our event graph. And now we can define the specifics of this attack. So this attack is going to go from socket 0 previous to current. And actually in our function as well, we're no longer going to want to reset those there, because then it's always going to be resetting the same ones. So now we can actually just drag this to the end here, and I think that's why I was a little confused. So once this function is done, no matter which rung it ends on, it's then going to reset our socket there. Then all we need to do is copy this, paste this in here, move this up here a little bit. We can change previous 0 to 1, we can change 0 to 1, we can change 0 to 1, and previous 0 to 1. Now if I go and swing, I've turned off the debugs. Now if I go and swing, you can see that we've got both the outside and the inside of our swing totally collision filled. But, there may be situations where when you're at a certain distance from the enemy, you're going to end up missing them. Let's see if I can find something like that here. It's pretty good because normally these would be line traces, and I've gone and copied stuff, so we're still using sphere traces, which is totally fine. It does make things a little more robust, especially for a system that's very realistic and causes the problem of missing an enemy entirely with a swing like this. So you can go ahead and leave those spheres if you want. I'm reiterating myself a lot. But one thing we do want to do now is we also want to fill in the center of our swing. And we can do that very easily, but we want to make sure that we don't reset the previous location of our socket until after we've done all of our traces. So I'm going to move these two down to the bottom here. Then I'm going to copy this up here and this up here. And then let's just go through and set up the center of our swing. So we're going to want to start, for our first swing, we're going to want to go from the current 0 to the previous 1. So I'm going to unpin these here. I'm going to change 0 to 1. And just do this here. And we're not going to be doing either of these because we're going to be setting those at the end to their new location. And then for our second swing here, I'm going to unplug these as well. We're going to want to go from our current 1 to our previous 0. And this is just going to trace backwards, forwards, and through our attack. So now if I go over here, you can see that we've got these traces in the middle as well. And that's just going to fill things in and make sure that it's pretty much impossible for this swing to miss, as long as the character is within the realistic swing of the animation. And maybe this is even a little robust for your project. This sort of system is much better for doing things like really fast swings. So I'm just going to go in here quick. I'm going to disable this. And I'm going to go back to the notify state, turn this back on here. So you can see that we've got all of these colliders that happen here. They're not very consistent because they all rely heavily on the tick. They just kind of appear whenever there's a tick during the swing. And that's going to cause a lot of problems if, say, you've got a character that's supposed to be like a ninja and they attack really fast. I'm going to go in here and I'm going to set all of these montages to be of speed 2. And you'll see now that when I swing my sword, we've got like no colliders here at all. They're just kind of like sporadically thrown about whenever there's a tick, and that's really not helpful. If I come in here and I disabled that now, come back to the combat character and drag this back up off of the tick. Even with a fast attack, it's still going to trace all the way through. It has less vertices to the swing because it's still adding the vertices every time that there's a tick, but the swing is going to be much more robust and actually follow all the way through the attack. And so if you have a lot of fast animations, that's probably the way that you're going to want to do things. And that's especially helpful if you've got things like ranged combat. If you've got a bullet or an arrow flying through the air and you want realistic collisions, you're going to have a collider attached to that projectile, and each tick, that collider is going to decide whether or not something is interacting with that arrow, which means it's possible to have a projectile on one side of an actor, check for collisions, it flies through the actor, and then checks for collisions on the other side, and it's not going to know what it hit. But if you've got something like a sphere collision, tracing a previous and a current, that's going to trace through the actor. It's even going to find the point in space that it hit the actor, so that you can still do things like have the arrow dug into an enemy or something like that, or the target, or whatever you're doing with that. going to quickly go ahead and set these back to the proper attack speed. Okay, so now we've got our system set up here, but the logic we're using is kind of clunky, right? Like, it's not very replicatable. We've got a bunch of casts in here in our animation blueprint, and you really don't want to have to do all these casts, especially once this starts to get much more robust. You've got different weapon types, and it's all just going to be very convoluted. So what I'm going to do is I'm going to go to our combat blueprint interface here, and we can just throw buffers in here for our notifies as well, which will save us from having to cast every time we try to call one. So we've got swing start, swing end, attack end, and combo break. So in here, I'm just going to go swing start, swing end, attack end, and combo break. These don't need to return anything, they're just pass-through functions. And then on the animation graph, we can delete this entirely and go swing start, swing end, attack end, and combo break. And then in our combat character, we're going to have all of these functions here. Because they don't return anything, they're going to be treated as events. So literally what we can do is we can actually just come in here and replace the events that we've created with those events. Okay. We don't have any compile errors, so that looks all good. Trigger attack is still only being called by this here, so it's totally fine to leave that as a regular event. We don't really need that in there at all. Oh, what have I done here? Okay. So that's going to make that a little neater for us to use there. Oh, I didn't replace swing end here. I thought I did, weird. So now if we go over here, everything should still work just the same. But we're not going to have to worry about all of these casts hanging over our head in the animation blueprint. We've already gone ahead and put this into a function here for the trace. And one thing that we can do actually is we can use this damage trace. No, we can't, because that's using the hit actors array here, which isn't going to be reset. Because we're clearing that here on swing start. What I'm going to do is I think this works just the same. We're actually going to clear our hit actors every time we start an attack. And then that's going to allow us to use this damage trace in our notify state event as well. And if we go ahead and look at this damage trace really quick, it's actually doing a lot of heavy lifting for us. It's checking to see whether the actors are hit, whether they're damageable. And then it's also applying the damage for us, which comes directly from the weapon, so we don't have to worry about any of that. So I'm going to go back to the blueprint interface here. I'm going to add a function called damage. I'm going to call it trace damage just because it's more of an active function rather than a idle function. I don't know where I'm going with that. And it doesn't have to return anything, so it's going to be treated as a event, and we don't want that. So I'm just going to come over here, and for the output, I'm just going to say return value. And that's going to allow us to treat this like a function. That's going to allow us to treat this like a function rather than an event. So if I come over here and go trace damage, that's going to open this for us. Then if I pull up the damage trace, we can connect. Oh, right, we want the start, the end, and the show debug in here. Which if we were to add, would still act like an event because they're inputs and not outputs. So you do want to make sure that you have that return value there at the end. And just so we have something to put into this return value, I'm going to jump into this function really quick here. And we want to know whether or not we actually hit anything. So I'm going to drag off of here and do a return node. Output, just call it return value. And then I'm just going to drop this in here. How can we do this here? Can I do this with a local variable? Let's find out. Hit vectors underscore L. I don't think this is going to let me return this. I don't know why they've had to go and change this. So on each instance of this function being called, this hit actors L is going to erase. So if we add unique hit actors to here, if they're not already in the actual hit actors of the actor, this is going to keep track of exactly how many actors were hit during this tick, which is what I'm looking for here, just to know whether or not this actual tick found any actors. So we can go off of here and go length. And we just want to know if this is greater than 0. Okay, that still works in an actor, it just doesn't work in a notify state. Strange. But we'll take what we can get, I guess. Or not, it doesn't work in a function library. I'll have to look into why that is and figure out a way around that. But we've got this here now. So in the notify state, what we can do is we still need, actually we don't need our weapon now because that's going to handle the damage for us. So I'm going to clear that. I'm not going to need to worry about that anymore or any of this. We can clear this. We are going to want our weapon sockets because that's going to define the start and the end. So we can get our weapon sockets from the owner. And we can also trace damage. And we don't want to call this function library 1. That's kind of left over from something that didn't quite work earlier. But we'd want to call the trace damage from our blueprint interface. Then here we can define our start and our end, and I want to show debug. So with that connected, if I come over here and disconnect this, we should still get this working just fine. And there we go. You could also add the radius of your trace to that event if you wanted to as well. You can do that however you wanted, but that's a good way to go through and make that work a little more expansively for bigger projects and stuff like that. It's just to make sure that you've got pass-through functions in an interface that pass through functions that you've got in your combat character. And this way you're actually don't even, in here we can delete this hit actors entirely. We don't need to use it in the notify end, we can actually just remove that entirely as well. And we don't need current weapon because we're not keeping track of that much information in our notify state. And we should still only see one print string there every time we do a swing. So there we go. I'm gonna go back in here and disable that quickly because we'll go back to this method over here. I don't know why I keep putting that on the begin play. And then we've got our more consistent trace here as well. Okay, and one more thing that you need before you can start doing good combat. Oh, yo Rex, how you doing? I hope you're still here. Thanks for tuning in. Nice to hear from you. It's been a while since I've done anything, so glad to see that people are still showing up and having a good time. If you're still here, how you doing? In the meantime, we are going to look at adding health to our character. So Unreal Engine 5 already has a damage system in place, and that is the apply damage that I put down here. But what it doesn't have is a health system implemented into their characters. And I could go ahead and I could add functions to the combat character to do the health and all of that. Because the combat character is going to be implemented by everything will get health instinctively. But I don't know, maybe you want stuff thrown around your level that has health as well. And how is that really going to work, right? You're going to have to implement it every single time. So what I'm going to do is in the characters folder here, let's make a new folder. I'll call it actor components. Then in here, we can drop off of here, go actor component. I'm going to call this AC health component. And we can add this component to anything that we want to implement health. And then rather than having to cast to something that's directly in the actor, we can actually just find out whether or not it has a health component and go from there. So for our health to work properly, we are going to want a max health, which is a float, and a current health. And then I'm also going to throw a third float in here, and I'm going to call this percent. And that's just going to make things a little easier as we go through later. So for the max health, I'm going to add this to a category called health settings. And then for the current health, I'm actually going to come over here to private and check mark that. I'm going to do that for percent as well. And then I'm just going to add them to a category called private so I know that that's how I set that up. But this way, when we add this component to something, the only variable that we're going to be able to change is the maximum health. Actually, you know what? Maybe I'll duplicate this as well, and we'll go with starting health. If you have some sort of saving load system or whatever, you might want to change the starting health. In this case, I'm just going to put starting health to 100 and maximum health to 100. And on begin play, I'm going to set the current health. Actually, we don't want to do that. We are going to create a function. I'm going to call this function set health. We're going to call this function set current health. And here I want to pass through 2 floats and a boolean. So the first float here I am going to call float. The second float here I am going to call value. And the third float here I'm going to call additive. This is how I like to set up stuff like this. It makes it really easy because you only need one function and it will handle everything for you. And for the output here, I'm just going to return a value just to keep track of whether or not the health has changed during this function call. So the first thing we want to do is I'm going to take this float Actually, no, we don't need this float. Because with our current health system, it's always just going to be the current health. So what we want to do is we want to set the current health here. I'm going to drag off of here. And I'm going to select. And I'm going to select based off additive. So if we are setting the current health, and we do not want it to be additive, then the current health is just going to be set directly to whatever this value is. However, if we do want it to be additive, then we're going to add whatever this value is to that current health. And this just basically is two functions in one. Rather than having a set and an add, we can do that here. And the value can be negative as well, so you can also use the additive to subtract. It's been a while since I've had a drink of water here. I hope you end up seeing this, Rex. I feel bad that I didn't respond to you in time. Still getting used to this whole streaming thing. I'm so used to making videos. Okay, and so now what we want to do is on begin play, we can drag this in, and actually, I'm going to go in here, and for additive, I want the default value to be enabled. So that by default, whenever we set the current health, it is going to be additive. And then in this particular case, we actually don't want it to be additive because we're just going to set it directly to the starting health. But every time we apply a change to the health, additive is going to be the default, which is what we want. And actually, I forgot about our return value here. So we're setting our current health. Before we do that, though, I'm going to grab current health, and I'm just going to promote this to a local variable called last current L. And then over here, I want to say last current does not equal current. And if they're not equal, then the health has changed, and this will be true. Ooh. Okay. So that's going to give us our begin play there. And oh, one more thing as well, before we end this function. We want to set this percent as well. And this is going to allow us to save a little bit of math doing other things. All you want to do is you want to take the current health and you want to divide the current health by the max health. And that gives you the percentage of health that you have. And I did make the percent private. So we do want to throw in one more function here, and I'm going to call this get percent. I'm going to make sure that this is a pure function here. And it's just going to return the percent. The current health is private as well. So get current health. Go ahead and set that up here as well. It's not really necessary to set up UI because we have the percent value, but it's helpful to just have this ready to go. And now we want to be able to see how much health the characters have, kind of just floating above their head the way that they were in the example. So over here, I'm going to go ahead and set up a widgets folder. And in the widgets folder down here under user interface, I'm just going to make a widget blueprint. Call it user widget health bar. And because I'm so used to Unreal Engine 4, the first thing I'm going to add here is a canvas panel, just to make things work the way I expect them to. Then we can drag in a progress bar. I'm going to make the size of this, I don't know, something like 175 by 15. Might end up being a little big, but it doesn't really matter too much. going to set this to 0.5 just to see what we have here as a starting point. And I'm going to change the fill to something like 1 red, 0.08 green, and 0.2 blue. Just a red value that I really like to use for health and stuff. I think it's very appealing. And on our graph here, what do we want to do here? We want to update our health bar based on the percent of the health component. And to do that, we can actually just pass it the component directly. So I'm going to go in here and I'm going to go health component. You can get health component. Get percent. This needs to be a variable called R. Then we can go set percent and just set that percent to the percent of the health component. Then we can go to our combat character here, because the combat character is where we're going to want that component. Drop that in here. And like I said, we've got our starting health and our max health, but we can't see the current health or the percent. And that's the way we want it. As well as that, I'm going to add in a widget. I'm going to call this the health bar widget. Space because I can. And the widget class here is going to be the UW health bar. And then I like to go in here and do draw at desired size. That's going to make sure that the widget is always the same size that you've set in your widget itself. And I'm going to drag that up here. And once you've got it roughly where you want it, you can come over here to the space and just change the world to screen, so that no matter what direction you're looking at the character from, you're always going to see the widget as if it's directly onto the screen. And just to make sure that the widget is going to work as well, because if I go in here right now, you're going to see that both of the characters have 0 health, because we haven't really set anything for the percent. And we're also going to get all these errors because there's no health component. What we want to do is we want to go over here. I'm going to get our health component widget, get the widget, and then we just want to cast this to a health bar. Then we can get our health component. Up here we want to go set health component to that. And now we have 100% health, but we're still not taking damage. So the last thing we need to do in our combat character is when we apply damage here, going to change the rotation, we're going to launch the character. But now instead of doing this print string, we can just grab our health component, go set current health. Additive is already true for us, which is nice, that's what we want. We can grab our damage here. We're just going to multiply the damage by -1, which should subtract the damage from our health pool. And there you go. We take 20 damage, or we deal 20 damage to the enemy every time we hit them, and then they eventually run out of health. And the way we can determine that pretty easily is if we come back over to our health component. I'm just going to make one more function here called isDead. Return value. And this is going to return whether the current health is less than or equal to 0. Because if they have 0, there's still no health there. So make sure that you include that bit. And then on the combat character, I'm going to throw in a sequence here. Actually, you know what? You're probably not going to want to launch the character and all of this garbage. If the character is dead, you're just going to want to play a death animation and treat that differently. So we're going to check to see whether or not the health has changed during this swing. If the health has not changed, then we're not going to want to run any of this stuff at all, so it doesn't matter. We can just leave that disconnected. And if the health has changed, we want to see if the health component thinks that the character is dead. We want this to be a pure function because we don't want to have to send an execution to it. And we can check again, is the character dead? If the character is not dead, we can set the rotation and launch the character. And if the character is dead, and this is the any damage of the character here, we can just go destroy actor. And this might give us an error because it's not the best way to do it, but let's see what happens here. So, gonna do these swings, and boom, the enemy has died. And there's no error because there's no other processing happening with the enemy. But if the enemy had AI going on, and it was still trying to process some of that, this is going to return major errors. So you'd really want this to trigger something on your AI, which is then going to stop all of its AI processing and then destroy the actor. Or even hide the actor and just get it ready to respawn, however your game handles that. But this is where you would want to put that. And that is more or less how you set up a combat system in Unreal Engine 5. I hope this was helpful. I definitely really enjoy using this kind of method. It makes things very convenient for when you're doing things like an action game and you want everything to be reliant exactly on where the weapons are swinging and where the projectiles are flying. This is the way to go. So yeah, I hope you had fun. I hope you learned something new. I hope this helps you with your game project. And I hope you have a great day. Take care.